The universe is the largest humanity has ever measured. But there is one problem. We have never traveled across it. We have never reached a star. We have never visited another galaxy. In fact, the farthest humans have ever traveled from Earth is the moon. And yet, somehow, scientists can tell you how far away stars are, how large galaxies are, and how fast the universe is expanding, and even how old it is. So how do we measure something we can never physically reach? This is one of the greatest scientific detective stories ever told. Imagine someone asks you to measure a table. Easy, you grab a ruler. A football field, you use a larger measuring tool. A country, a continent, a planet. Eventually, you run into a problem. The universe is too large for any measuring tape, any spacecraft. Too large for direct measurements. And yet, somehow, humans find a way. The answer begins with a simple illusion. Hold your finger in front of your face. Now close your left eye. Notice something strange. Your finger appears to shift. But your finger did not move, only your point of view changed. This effect is called parallax, and surprisingly, it becomes humanity's first tool for measuring distance beyond Earth. As Earth moves around the Sun, our viewpoints change. Scientists observe nearby stars from opposite sides of Earth's orbit. The stars appear to shift slightly. Tiny movements, almost impossible to notice, but measurable. Using geometry, scientists calculate the distance. No spacecraft required. Earth's orbits become a giant measuring tape. For the first time in history, humans could measure the distance to stars. But the further a star is, the smaller the shift becomes, until eventually the movement becomes too small to detect. Humanity's first measuring tool stops working. It seems like the universe has defeated us. But then, something extraordinary was discovered. Not all stars shine steadily. Some of them push bright, dim, bright again, like distant cosmic lighthouse in the dark. Those stars are called Chevy variables, and they will unlock a completely new way to measure the universe. Scientists discover something remarkable. Hidden in the stars is a predictable relationship. The brighter a Chevy truly is, the slower its push. By measuring that push, scientists can determine its true brightness. They compare its true brightness to how bright it appears from Earth. From that difference, distance can be calculated. It's like looking at a street light in the night. If you already know how bright the bulb is, you can estimate how far away it is. Suddenly, distance was no longer limited to nearby stars. We could now measure far beyond them. Entire galaxies become measurable, but the universe still has larger scales waiting. Then come some of the most powerful explosions in the universe, type A supernovas. When those stars explode, they can outshine an entire galaxy. And because they reach nearly the same brightness every time, they become standard cosmic light bulb. Scientists compare actual brightness to observed brightness and calculate enormous distances. Millions of light years, then billions. The universe opened wider than ever before. Then comes a discovery that changed science forever. Astronomers noticed something strange. Galaxies are not sitting still. They are moving away from us. And the further away they are, the faster they move. This discovery comes from Edwin Hubble, and the clue was hidden in light itself. Imagine an ambulance driving away. Its sound stretches lower. Light behaves similarly. When galaxies move away, their light stretches, becoming redder. This is called redshift, and it reveals a shocking truth. The universe is expanding. Space itself stretches, meaning reality grows larger every second. For the first time, humans were not measuring distance. They were measuring the evolution of the universe itself. Then scientists discovered something extraordinary, a faint glow filling all of space. Ancient radiation left behind by the earlier universe. The cosmic microwave background, the oldest lights ever observed, a baby picture of the cosmos. By studying this ancient signal, scientists learned the age of the universe, its expansion history. This becomes the blueprints of the universe. By now, scientists have built a chain of measurements. One method calibrates the next. Parallax measure nearby stars. Chevy variable measure further stars. Supernovae measure galaxies. And redshift measure the expansion of galaxies. Together, they form the cosmic distance ladder, a staircase stretching from Earth to the edge of the observable universe. So how did humans measure the universe? Not with rulers, not with giant spacecraft, but with geometry, light, stars, explosions, and ancient radiation. From one small planet orbiting an ordinary star, humanity learned the size, age, and the structure of the observable universe. The universe might be unimaginably large, but curiosity allows us to measure it anyways. If you love cosmic mysteries and want to understand the universe one layer deeper, subscribe, because every answer about space leads to an even bigger question.